Hi everyone. Here is your entrance ticket or warm up for Tuesday or day 7, I believe. So hard to believe it's only one question, which is why I tried to assign fewer. And this one's a little weird because we're talking about distance kind of in a negative, meaning I'm below the surface of water. So I thought it'd be a good one to do together. So the question is, or the problem, whatever. Two submarines are underwater and begin to ascend, meaning go up to the surface at the same time at a constant rate. So good to know, constant rate of change means we have a slope. So submarine A starts at 900 feet below the surface of the water and ascends at a rate of 150 feet per minute. I'm not even going to get into that, but that's good for us. Submarine B starts at 400 feet below the surface of the water and ascends at a rate of 50 feet per minute. All right. First wants us to assign variables. What does X represent and Y represent? And then do some equations. Now I'm going to kind of cheat and skip down to the questions because oftentimes our questions will basically tell us our unknowns because they want us to find them. So the first one is how many minutes until the submarines be the same distance. Well, my bad. Until the submarines are the same distance from the surface. Good thing we're going over together. And what will that distance be? Boom. 2 questions there. Minutes and distance. So I'm going to have X be my time after they start ascending, right? So when they start ascending is kind of our starting time because they start at the exact same time. It says it in the first sentence. And so it's the time that they're ascending, minutes and that they've been ascending. Number of minutes since, we'll just say, because I can't really fit anything else, okay? So since they start ascending upward, so the number of minutes that have passed. Oh, minutes that passed, that would have been good. Anyway, the next one is that distance. Well, we know that they're trying to get up to the surface. So what we're gonna say is maybe distance below surface. And again, we're gonna be dealing with it in negatives. My cue to know that is here that instead of my x-axis, from my x-axis going up, it goes down. So my y is going to be distance to the surface. Okay, and we are vague on those because again, the distance to the surface is going to be different for submarine A as it is for submarine B. So don't make those 2 things your unknowns. Okay. Another hint, guys, is if a graph is included. Again, that's my x-axis, time passed in minutes, and then distance beneath the surface of water in feet. Okay, so now, submarine A is distance below the surface. So we're going to go back to the sentence, and I said, ooh, this is good for us. Because here's what it says. It starts at 900 feet. Okay, 900 feet below. That is our starting point, or our y-intercept, right? And then over here, we have a rate of change. And we know it's a constant rate of change because, again, it says it up here. And that's 150 feet per minute. Now remember, that's the slope. So what we have is for this, submarine A, y is equal to the slope is 150 feet times x times the number of minutes, right? That's how many it's gone. And because it's below the surface, remember, it's not positive 900 feet. It's minus 900 feet. All right. The next one, submarine B. When we look at submarine B, again, we have a starting point, which is 400 feet below, and we again have a slope, which is our rate of change, 50 feet per minute. So its distance from the surface at any given time is y equals, and then the slope is 50 times x, because every minute will be 50 more. So 2 minutes, it will have gone 100 feet upward. And again, since it's below the surface, it's minus 400. Okay, great. Now we have our 2 equations and we are going to graph them. And I'm going to try and color coordinate and I'll label them A and B. So here we have 250, and then 1, 2, 3, 4, 5. So these must be going by 50s, right? 550, 6, 650, 7, 750, 8, 850, 9. So this must be negative 900. Okay, I start here. It's my starting point for the first one. And I go up 150 and then right only one, because it happens at every 1 minute that passes. Remember, each of these are 50. So 50, 100, 150 over 1. Okay, that is plus 150. I'll write that there. And then again, now I know that that's 3 squares. I'm going to go up 3 squares over 1, or 3 over 1. But really, it's 150 over 1. Good. Okay. Now I even use my straight edge and put a little A next to it for submarine A. Great. Now my next one is at 400. So again, these go by 50. So if I'm at 50, that's 50, 3, 350, 4. So here's negative 400. Awesome. And now I only go up 50. So remember, 50 is one of those squares. So it's going to go up one square. 50 is only that one little tiny square you can barely see. It's about 150. I wrote a plus sign. It's just really small. So 50 in 1 minute. So 50 over 1, up 50 over 1, up 50 over 1. And so on until we feel good. And I love it when it crosses at the exact same dot, like my favorite part. Or when the line passes through all the dots in the calculator. You guys do that. And that is submarine B. Great. Now we got to ask or answer some questions. So again, it says how many minutes until the submarines will be the same distance from the bottom or from the surface, and there we go. So remember, that has to do with our solution. The solution is when they are at the same place at the same time. So let's figure out what this is. First, it's over 5, comma, and then down 50, 100, 150, negative 150. So it says how many minutes until the submarines will be at the same distance from the surface, and what is that distance? So here, we know at, or after maybe is a better phrasing, after 5 minutes, both subs will be 150 feet below. Did I give myself room? Okay, notice I didn't write negative 150. Even though this is a negative 150, up here, these are negative 900 and negative 400, but they didn't write it that way. The phrasing of the word below implies a negative. So instead of writing below negative 150, we just use below, and that implies a negative. Then it says, when is submarine A below submarine B? Well, A is purple. Notice from the start all the way to 5 minutes, the purple line is below green line. So that must mean that submarine A is lower than submarine B during this time. So that is from 0 to 5 minutes. Now, if you're ever confused on how to answer these questions, you use the question word. When implies a time period. The next question is, when is submarine B below submarine A? Well, here at this point, since they're straight lines, they cross, which means they switch positions. So after that, B is below, and it would be all the way into B surfaces because you can't go further than that. So it looks like B surfaces at 8 minutes. So from 5 to 8 minutes. Okay. Lastly, it says submarine A will hit the surface first, just right there. How long does submarine A wait at the surface for submarine B? Well, here I already did some of the work for us. Submarine B hits here at 8 minutes. When does submarine A hit? So from 8 minus 6 is 4, so 4 2 minutes. All right. Please let us know if you have any questions and have some fun.